Seated on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be discussing object references in Python and how objects are represented in the computer's memory. So as we've covered in a very early lecture, when we talked about variables, Python doesn't store the value directly in the variable. Rather, it stores a reference to an object that exists in the computer's memory. This reference is basically the location of where this object resides in the computer's memory. And the same is also true when we're creating our own classes and our own instances of those classes. Here we have a very simple class called dog, and it has two instance attributes, name and breed. And all it does is it sets up those instance attributes and assigns them a value. So in the last line here, we're creating an instance of this object with a name of Laddie and a breed of Collie. So how does this work under the hood? Well, we do create a variable called myDog, but it doesn't store the instance in this variable. Rather, this variable points at an area in the computer's memory, something like this. It does this by storing the address of where this instance exists. And in this case, this instance stores the name Laddie and the breed Collie. Both of these are instance attributes. And we can get a better idea of this is if we try to actually print out the value of myDog. So if we added a print line like here, where it says print myDog, what we would get is something that looks like this, saying main.dog object at, and then this big string of numbers. So what this big string of numbers is where this object is located in the computer's memory. This is how we reference the object. Now, to make this a little bit more interesting, what we can do is create another instance. So in this case, we're creating a second instance of dog for a dog named Gaspode, and he is a terrier. And this is going to be stored, or at least the reference to this is going to be stored in a variable called neighbor_dog. In this case, neighbor_dog is going to point to where this is located in the computer's memory, and that is going to have an instance attribute name of Gaspode and an instance attribute breed of terrier. So if we added print lines for both, we could see it print something very similar, but the addresses are different because these are pointing to different objects in the computer's memory, which is why they all have their own name and breed. But again, we can make this even more interesting when we try to assign myDog to other dog. Now, based on everything we've seen before in Python, when we're doing this with like lists or sets or other objects, what do you think is going to happen here? Is this going to make a copy of myDog? Is it going to have two variables pointing to myDog? Maybe it'll give us syntax error. Think about it for a bit. I'm going to put up a timer and unpause when you think you have the answer, and we'll take a look.
Lines of code on screen again. Python's flowing through my pen. Hourglass is running out. Gotta solve this right, no doubt. Deadlines looming, it's so tight. Tick-tock goes the clock at night. Functions, loops, and ifs and elses. Each line fixes all my messes. Coding fast, time is slipping. Got no pause, pressure's gripping. Python rhythm, keep on beating. Countdown timers, never cheating. In the zone, my mind's a maze. Debugging errors that we face. Syntax highlight, guiding way. Hope to reach the break of day. Pulling through each iteration, a variable dreams never ending. Python logic with...
And we're back. Let's see what this does. And what this does is it creates a new variable called myDog, and this is going to point to the same instance of myDog. Now, It's important to note here that this isn't making a copy. Both of these are pointing to the same area in the computer's memory. And we can see this when we add some print statements. Here we're going to print out the value of each one of these objects. And we can see that both my dog and other dog are pointing to the same memory address, whereas neighbor dog is pointing to a different memory address. This is because both my dog and other dog are references to the same object, my dog, and neighbor dog is a reference to a different object. And this is important because it changes what happens when we start manipulating these objects. So now we've added a new line that says mydog.name equals Big Fido. What this does is it's going to access this object's name attribute, and it's going to update that to Big Fido. So we can see here that my dog is a reference to this object where we had name Laddie, and now we've updated that name to Big Fido. What's interesting though is if we do the same thing but for a different attribute through other dog, because both my dog and other dog point to the same object, saying other dog.breed equals poodle is also going to update the breed for both of these. It's going to update it for my dog and other dog because they both point at the same object. They are the same object. So we can see this when we start printing out the values. These lines simply print out both attributes for each one of these objects, my dog, other dog, and neighbor dog. Now, unsurprisingly, because my dog and other dog reference the same object, we're going to get the same values here. They're both going to be Big Fido, and they're both going to have a breed of poodle. Updating one affects the other. However, neighbor dog is pointing at its own object. It's not connected to my dog or other dog, so changing their attributes has no effect on neighbor dog. When working with objects and classes in Python, it is important to keep track of which variables are referencing which objects. And luckily for us, Python does provide us a way, or an operation in this case, to check if two variables are referencing the same object. And these operations are is and is not. We can use these keywords to check if two objects share a common reference. Are they the same object? Let's take a look at what this would look like in our code. So we've added two lines here. The first one is checking my dog is other dog, and my dog is neighbor dog. And what this is operator is going to do is it's going to return true if my dog and other dog are referencing the same object. Or in the second line, if my dog is neighbor dog. If both my dog and neighbor dog are referencing the same object, that would return true. Otherwise, it's going to return false. So let's see what we get for output. Well, for the first line, we get a true, and the second line, we get a false. And this makes sense based on the diagram we have on the screen right now. My dog and other dog are both referencing the same dog, who in this right now has a name of Laddie. Whereas my dog and neighbor dog reference two different objects. One's for a dog named Laddie and one's for one named Gaspode. This means we get a false because they aren't referencing the same object. So is and is not can be quite useful for checking if our variables are referencing the same object. Is not works the same way except the output's flipped. If they're not referencing the same object, we get a true, and if they are, we get a false. So one question you might have is, how is this is operator different than the equality operator, which is represented by two equal signs? Well, there is some overlap here, and in the default case, they do operate the same way. But there are some key differences. The is operator is used for comparing identities, which means that it checks if two objects are the same objects in the computer's memory. So it's going to return true if both reference the same point in the computer's memory, which means they're the exact same object. Whereas the equality operator, by default, is going to do the same thing. It checks if two objects are the same object in the memory, just like is does. But there's an important distinction, and that is classes can redefine what equality means for that class. So for example, instead of checking if they reference the same point in the computer's memory, they can redefine the EQ or equals method to say that we're now equal if we have the same values. And there is a slight difference between having the same values and having the same location in the computer's memory. We can have two instances of dog, for example, that have the same name and the same breed, but that doesn't make them the same object. There'd still be two distinct objects in the computer's memory. So use is when you want to check if two variables refer to the same object in the memory, and use equals equals, or the equality operator, when you want to compare the values or the contents of the two objects. Now, there is another tool that we can use when we're trying to check if two objects are similar, and that is the isinstance function. This doesn't check to see if two objects are the same object. Rather, it checks to see if an object is an instance of a particular class, which can be helpful if we don't really know what sort of object we're getting passed into a function. We can use isinstance to figure it out. So isinstance is a built-in function, and it's used to check if an object is an instance of a given class or a subclass of that class. I'm not really going to get into hierarchies of classes in this course or inheritance, so don't worry too much about what a subclass is. For our purposes, isinstance is going to tell us if an object is an instance of a particular class. And it's going to do that by only returning true if the object is an instance of the class or a subclass that's specified. So let's take a look at the syntax. And we call this with two values, or two arguments. The first is the object being tested. This would be a variable that references an object in the computer's memory, and that we want to figure out if it's an instance of a particular class. Second argument is going to be the class to check if this object is an instance of. Let's try this out in an example. And here we have the same dog class as we already saw in a previous example, but now we also have a new class named cat. This class is very similar to the dog class. It also has an instance attribute named name, but it also has an instance attribute named color. But for the purposes of our example, the most important thing here is that it is its own different class. What we're doing with this is we're creating two instances, one of the dog class and one of the cat class. Pet1 is going to be a reference to an instance of the dog class for a name of Laddie and a breed of collie. Pet2 is going to be an instance to the cat class for a cat named Maurice, and they have a color of ginger. And what we're going to be doing with these objects is we're going to be testing them with the isinstance method. And we're going to be checking if they are an instance of the dog class. The first if statement is going to check if pet1 is an instance of dog and then do things based on that. And the second if statement is going to be comparing pet2 and seeing if it is an instance of dog, and then doing things based on the result of that. So when we give this a run, we're going to get the result of pet1 is a dog and pet2 is not a dog. So how did this work? Well, this pet1 is a dog is printed out by the first if statement. It's checking if pet1 is an instance of dog, and the isinstance method returns true in that case. It is an instance of the dog class. So we run the true case, which is pet1 is a dog. Now for the second line, pet2 is not a dog. It's very similar. It's being printed by the second if statement. In this case, we're saying is instance pet2 a dog. Pet2 is an instance of cat. So this is going to return false, which means we run the false case, which is pet2 is not a dog. This isinstance method can be very useful for checking to see what an object is. Is this an instance of a particular class? And that can be very useful if you're getting a parameter from a function or into a method, and you need to know what it is before you do something with it. Now, another way that we access these objects for a reference is the self-reference. And we've seen this a few times in more practical examples, and we know that we use this to access instance attributes and instance methods. But how is this working? Well, here we have that dog class again, except we've added a new method called sayName. What this does is it simply outputs woof, the name of the dog, and then woof again. But the important detail here is that self keyword. It's also the parameter, and the only parameter to the sayName method. And we know from previous examples and videos that this is accessing the instance attribute named name to get it and put it in our print statement. But how is this working? Well, self is a reference to the object, just like the other variables we've seen. The key here is that when we call the sayName method, it is passed along as the first parameter. Having this as the first parameter creates a new reference to the object called self that we can now see in this diagram, and allows us to access that object. So in this case, we'd access the name and include that in our output. Now let's say we had a second instance of the dog class, neighborhood dog again. Now when we call save name on neighborhood dog, what's going to happen is the reference to neighborhood dog is going to be passed as an argument to the self parameter. So now when this method is called, self isn't going to be equal to my dog, it's going to be equal to neighborhood dog. So we're going to have a new reference to the neighborhood dog object. So when we call this, it's going to print out the name of the neighborhood dog instead of my dog. So that means our output is going to look something like this. The first line that was caused by the call to my dog say name is going to output woof, laddie, woof, because laddie is the value of this name instance attribute for my dog. Now the second line is going to be woof, gaspode, woof, because neighborhood dog has an instance attribute name equal to gaspode. So what self is equal to changes each time the method is called based on who is calling that method. Now don't forget that we can also use this self reference or any object reference to call methods. So in this case, I've updated the dog class to add a getter called getName, which simply returns the current value of the name attribute. We've also updated the sayName method to call on the getName method rather than using self-name directly. So what this does is it uses the self reference to call on getName. So whatever self was equal to is then passed as an argument to the self parameter in getName, and then it returns the value of the name attribute. Now the other thing we should talk about is the none object. And this is a special object that we've seen in a few past lectures. And it's special for two reasons. First of all, it represents nothing or no value. And second, it's a singleton object. What we mean by singleton is that there is only ever one instance of none in Python. So all none objects always reference the same object in the computer's memory. So what do we use none for? Well, we use it for a few reasons. We use it to signify the absence of a value, a default initialization, or a placeholder for an object for values that haven't been assigned yet. So let's take a look at an example. Let's say we wanted to add a owner attribute to the dog class, but we haven't set it yet. We might start that off as none, and we'd do that simply by saying it equals none, and this would be a reference to the none object. So setting something equal to none on its own isn't very helpful. We also need a way to check if it's equal to none. And luckily for us, we just saw two operators that could be helpful with that. And those would be the is and is not operators. Now, because none is a singleton object, that means regardless of how we set something to equal to none or where it was set as none, anything equal to none will always reference the same area in the computer's memory, which means that is and is not will always return true if we're comparing it to none and it currently is equal to none, regardless of how it was set to none. Let's take a look at an example. And in this example, we're creating an instance of that dog class that we saw. In this case, the dog is going to be named Laddie, and they're going to have a breed of collie. And we're going to store a reference to that object in the variable myDog. Now, interestingly, after that, we have a second variable called notSetYet, and that's going to be equal to none. We might do this as maybe somewhere further on in the program, we were going to give it a value, but we needed it defined now, even though it doesn't have a value yet. So how could we actually check if it's none? Well, as you can see on the screen, we have two different if statements that do that check. The first if statement is checking if notSetYet is none. That's going to return true if it is currently referencing the none object. The second if statement is checking if myDog is none. So when we run this, we would get this output. We have notSetYet is none, which is printed by this first if statement, and that's because it returned true. It is none. So it says notSetYet is none. Now, the second line is printed by the second if statement. In this case, we're checking if myDog is none. Now, because myDog actually points to a real object, a dog object with the name of Laddie, then this is going to return true because it's not currently pointing to that none object. So we get the output, myDog is not none, because this returned false, and we ran the false case. Now, there is a common error to be aware of when you're dealing with none objects. And that is when you try to access a method or an attribute on a none object, it's not going to work. The none object isn't an instance of any real class, so that means it's not going to have attributes or methods for you to access. Let's take a look at an example. Again, we have that not set yet variable, and it's going to be a reference to the none object. But now we're going to try to do some things. We're trying to access the name attribute, sort of like the dog class has. If we tried to run this, we would get an attribute error because the none object isn't going to have an attribute name. Similarly, we couldn't access a method or call a method like this because the none object doesn't have methods. So again, this is going to give an attribute error. And lastly, we are trying to print out or access the instance attribute breed. But again, this isn't going to work because the none object doesn't have any attributes. So when you're working with none objects, be sure that you never call a method on them or try to access an attribute because that's going to lead to an attribute error. So always make sure that you update their value to something that makes sense, maybe an instance of a class, before you start trying to access attributes and methods on them. The last thing we're going to talk about in this video is the object lifecycle. And this refers to the 3 distinct stages an object goes through in Python. Those are creation, usage, and destruction. In creation, an object is created. This happens when we make an instance of a class. Memory is allocated for the object, and then its init method is called. The init method sets up any instance attributes and calls anything else we need or sets up anything else we need to set up that object. After that, it enters the usage stage. And this is where the object exists and can be accessed, modified, and we can call methods on it and so on. During this stage, attributes and methods of the object can be accessed and called. And the final stage is destruction. This occurs when an object no longer has any references to it in the program. That means there's no variables that reference or point to this object. When this occurs, Python's garbage collector will automatically free the memory used by the object, and there'll no longer be any way to access that object. Now, if the object defines a delete method, that would be 2 underscores, DEL, and then 2 underscores, that method's going to be called just before its destruction. So just like init allows us to set up things, delete allows us to shut down things or get things ready for the object to be destroyed. Now, there's a few ways we can lose references to an object. They can simply go out of scope. For example, if an object was referenced by a local variable in a function, and that function finishes maybe by calling return, then that reference is going to be lost. So there'll be one less reference to that object. Another way we can explicitly get rid of a reference is with the del or delete keyword. That allows us to tell Python to remove this reference from the object, and once all references from an object are gone, it's destroyed. So this brings us to reference counting. An object is destroyed when its reference count drops to 0. Each reference created to the object increases the count by 1, and each deleted reference lowers the count by 1, whether that's an explicit deletion or one that happens through other means. Let's take a look at an example for the delete keyword. And in this example, we are making an instance of dog for a dog named Buddy who has a breed of pug. Let's take a look at how this works. So in the first line, we make that instance. So in the computer's memory, this instance exists, and we're making a reference to this instance. In this case, A is going to reference the instance. That means we have a reference count of 1. At this point, there's at least one variable that's referencing this object. Now the next line creates a second reference to this object. Since we're just saying B equals A, this doesn't create a new object, rather it just creates a new reference to the object, which increases the reference count to 2. Now on the next line, we delete a reference. We delete the reference A. And this lowers the reference count to 1. We can still access this object fine through B, we just can't access it through the A reference anymore. Now on the next line, we delete the last reference, B. So the reference count drops to 0. When the reference count drops to 0, it means eventually Python's garbage collector is going to come by and it's going to free up that memory. It'll delete the object. Now, It is important to note that when that occurs isn't really defined. It's up to the implementation of Python we're using. All we know is that it will eventually occur when there's no longer references to the object. And when that happens, it's going to call that delete method in the object, which can be customized to do different things. Now, in our next video, we're going to be taking a look at special methods like delete. So if you're interested in that, make sure you watch the next video on special methods in Python. We also sometimes call those the magic methods. But that's all I have for you in this video. Thank you for watching and have a great day.